Okay, this is the mission 54 organized by Space Analog Station Habitat Marte. And then today we have the presentation of Pallavi Prasad. Okay, Pallavi, now you can share your screen, okay? Thanks.
Hello, good morning, good soul, everyone. So, this is mission 54, wherein we are going to discuss propellant production on Mars. And this is a mission organized by Habitat Marte. So, uh, in this presentation, particularly, I am going to talk about Starship and the propellant production and its storage, and the capability of starships, that how it is capable and feasible enough to reach to Mars. So, and it is broadly divided into two categories: one, production and storage of propellants, and the possibility of storing fuel in Starship tanks. So, first of all, we have talked a lot about the production of propellant, and in my launch facility development, I have already talked about the feasibility of liquid propellants, and that is what we can have there, and a which is in this case is Starship. So um, during that, we have come up with that uh, hydrogen, liquid oxygen, and liquid methane will be a propellant as a rocket fuel we are going to use. And we have earlier talks about that how we can come up with a propellant production. So we have there are in situ resource utilization unit, which we need to develop first, even before humans reach on Mars. So what two things we have to come up with? We have an ISRO instrument for water mining, and then through electrolysis convert the production of oxygen, liquid oxygen, and through Sabatier process, we need to convert we need to collect CO2 from the atmosphere and convert it into methane. And then post that, once it is done, we need to liquefy it and store it. So for the storage point here, it will be directly to the Starship propellant tanks. So on Mars, we'll see later, there will be a storage fuel stations basically, wherein we will be filling these fuels directly to the propellant tanks, the Starship propellant tanks. So going forward, first of all, I'd like to take you through some of the key highlights of a Starship profile. We are going to discuss only Starship here because as of now, what I have understood, this is the only Starship, this is the only transmission system which is capable of reaching to Mars and back. So on a key highlight level, it has a payload which has a capability of 100 plus ton, and until Leo. After that, Leo, that means low Earth orbit, and after that, you need to refuel it so that we can reach to Mars. So this is the payload capacity is, like I said, it's 100 plus ton, and the propellant capacity is around 1200 tons. This is the super heavy rocket part. So basically Starship is a combination of a Starship satellite and a super heavy rocket. So the base part is the super heavy rocket, and it is a two-stage engine. So here this has a propellant capacity of 3,400 tons, and it can produce thrust up to 72 million Newton. And it is capable of carrying both crew as well as cargo. So for the crew part, it again the useful mass part is having, it can hold up to 100 plus ton, and payload volume of around 1100 meter cubes. So the cargo also, you can see it can hold cargo, and it is capable of transporting cargoes as well. And it has a payload which can actually hold up to 1100 meter cube, and a useful mass again of more than 100 tons. So even in this case, the cargoes can also carry crew depending on the situation. And it has a engine as Raptor engine, which is again capable of producing thrust of 2 meganewton. And so we'll talk about that how we actually reach to Mars using this Starship transportation system. So this is an overall architecture of it. So like I earlier mentioned, this is fully reusable rocket, and it is a two-stage rocket. So once you reach to Mars, the same rocket will be utilized to come back to Earth. So there is no loss in between. And so what happens is from the launch from Earth, so it reaches like at the first stage separation happens, where the booster separates itself, and then once you reach the second stage happens at once you reach at the low Earth orbit. So at this point, what we are also doing is we are refueling this ship with the with 100 ton around 100-ton fuel. So that will happen that at the same time there will be another fuel tanks will be shipped to Earth orbit. There the refueling will happen, and then the ship will be ready to move to Earth. Move to Mars. So after that it will start its orbit to Mars, and once it will reach to Mars orbit, it will change its angle, and then it will, using its 6 legs, it will land on Mars. And once it land on Mars, till then all the fuels are exhausted, so you need to have a fuel station refuel it. So there this ISRO instrument will come into picture. Just now we have seen that how MOXIE will work. So similar, and I've also explained we need to have both hydrogen a water propellant plant, and an ISRO for water collection, water mining, and an ISRO instrument for carbon dioxide, and to go through a Sabatier process and come up with a liquid oxygen. So, and once the refueling happens, then the same rocket, the ship is again ready to move back to Earth, and the heat shields are designed in such a way that it can sustain more than one flights. So it is completely reusable, we can see, and again it will come into Earth's orbit and then change its direction and land on its own 6 feet. So there is a quick simulation which I would like to show you, that how the transfer happen, how the transportation happen, and how it will land on Mars. I'm sorry for the delay. I think there is some internet uh, connection problem. Yeah. So this is where we can see the entry. After the entry, it is changing its direction and how it will land. We can see it here, that how it is moving and how it is descent path. Yesterday also I showed about that, how the descent will happen and how. So after entry into the Martian atmosphere, it will move, it is changing its direction, and then it will land on its 6 feet. Yeah, so a little more closer look that what will happen in the end. And gradually it will move on. Yeah, so this is how the landing happens. Yeah, so we have seen then how Starship will land, how it will move from Earth's orbit to Mars orbit and then land. So now we'll talk about how the fuel is going to be stored in this Starship tank. So it is basically the Starship, this transportation system is divided into three parts. It's first is engines. We have seen the Raptor engines are going to be used. The propellant tanks, which will hold both propellant and the fuel, and the oxidizer and the fuel, and the payload section, the front part, the payload section. So the payload, it is, this is designed for the Mars transit particularly. And this is here, we have a fuel tank and an oxygen tank. The lower section is the fuel tank, which will hold your liquid methane, and the oxygen, like liquid oxygen. And the same tank will be refueled again when you are on Mars surface. And this is the Raptor engine. And about the refilling it, so we have talked about the that once this ship is on the way to Mars at the Leo stage, where just before the second thrust second stage, it will have to be refilled, which will be done through another ships from Earth. And on in the orbit, basically it will link this with the existing Starship there, and the refilling will happen at that time. And yeah, so this is how we are going to go. I think SpaceX has already plans that how we are going to reach our goals and how we are going to reach Mars. So from their 2017 ISC presentation, I can see that they have a plan like by 2022 we will first have a cargo mission where we'll go to Mars and set up the ISRO plant, a propellant production plant, and then by 2024 the mission will be a crewed mission, and so that we have all the possible resources available to come back again to Earth. So yeah, so this is in continuation with the launch facility which we were talking about, and now we have seen that how Starship can complement our the launch facility setup. Yeah, thank you so much, and thanks everybody from the crew. And these are my references in case you want to go in detail.